This is a video on heat-seeking particles. The question states, find the path of a heat-seeking particle placed at the point 2, 1 on a metal plate with temperature field T of xy is equal to 40 minus x squared minus 4y squared. So I'm going to call this path r of t, and I'm going to write it in vector form and say that r of t equals x of ti plus y of tj. And I want to find the direction of that path, or in other words, I'm going to take a derivative of both sides so that r prime of t equals x prime of t I plus y prime of t j. Then I'm going to use a big theorem that says the gradient vector is in the direction of maximal increase, in this case of the temperature. So the gradient vector of t, the partial derivative of t with respect to x is negative 2x, and the partial derivative of t with respect to y is negative 8y. So the gradient of t of xy is equal to negative 2xi minus 8yj. The gradient vector and the direction of our path must be parallel, because remember, the gradient vector is in the direction of maximal increase, and heat-seeking particle means we're going to seek the maximal increase in temperature. So I can say that these vectors are parallel, or in other words, they're constant multiples of each other. So that means that negative 2x is the constant k times x prime, or dx dt, and negative 8y is the constant k times dy dt. And I can start doing a little algebra and divide by negative 2x and multiply by dt over k on this side to get dt over k equals dx over negative 2x. And similarly, I can do algebra and say that dt over k is equal to dy over negative 8y. So I can state that dy over negative 8y is equal to dx over negative 2x. Next, I'm going to multiply left and right by 8. 8 divided by 2 is 4. And then cancel the negatives and integrate both sides. And I get the integral of dy over y is equal to the integral of 4dx over x. The integral of dy over y is the natural log of y, and the integral of 4dx over x is 4 times the natural log of x plus some constant, which I'll call c1. So I get natural log of y equals 4 times the natural log of x plus c1, and I exponentiate to get y equals e to the natural log of x to the 4th. I use a power rule here and brought the 4 upstairs, plus c1. Then I can break up this exponential and write it as e to the natural log of x to the 4th times e to the c1. c1's a constant, so e to the c1 is also a constant, which I'll call c, and e to the natural log of x to the 4th is just x to the 4th. The e to the natural log canceled. I'm almost done. Now I just need to use the fact that this particle is placed at the point 2, 1. So that means if I plug in 2 for x and 1 for y, this equality should hold. So 1 equals c times 2 to the 4th. 2 to the 4th is 16. So c is 1 over 16. So that tells us that y equals 1 over 16 times x to the 4th, or x to the 4th over 16. So I can conclude that the path of the heat-seeking particle placed at the point 2, 1 is y equals x to the 4th over 16. And I'm done with the problem.